Hey guys, Mr. Backward here. In this video, we're going to find slope and rate of change. When we're talking about the slope of a line, the slope is a ratio that compares the vertical change, so how much your line is moving up or down, which we call the rise, compared to the horizontal change, so how much you're moving left or right, which we call the run. So when we're talking about the slope of a line, there's a few different ways that we can talk about it. One of the ways that we look at it is making a fraction, and we compare the vertical change, which we called the rise, and we put that over the horizontal change, which we called the run. Now, we will be looking at slope graphically as well. So when we talk about the rise, or when we talk about the vertical change, when you think about a graph, or if you think about ordered pairs, vertical change deals with your y values on your graph. So we could say that the rise, we can also call that the change in our y values, and the run going left and right deals with your x values, so we can say that the run is the change in our x values. Now there's another way that we could write this. A lot of times you see change represented by the Greek letter delta, which looks like a triangle. So we could say the change in y, we could call that delta y, and the change in x, we could call that delta x. So all three of these fractions are saying the exact same thing. The rise means the change in the y values, which can be represented as delta y. The run means the change in the x values, which can be represented as delta x. Now, there are four different types of slope that we could run into depending on what our line looks like. On this first one, on the far left-hand side, this red line, as we read it from left to right, this red line is going up. So we would say that that line has a positive slope. Now, if we compare that to our second picture, our blue line, this blue line is going down as we read it from left to right. So we would say that this line has a negative slope. In our third picture, this purple line is a flat horizontal line. When you've got a flat horizontal line, we say that that has zero slope. And in our last picture, this green vertical line going straight up and down, we say that that line has an undefined slope. When we're looking at finding the slope of a line, looking at a graph, what we want to do are try to pick out some points on the graph that cross at intersections of our grid lines. So I'm looking at this point right here on my red line, and if I trace on my line and try to find another point where our grid lines intersect, I'm also looking at this point up here. So I'm going to focus on using those 2 points to help me find the slope of this line. Now, we said for the slope we were going to look at the rise over the run, and we said the rise meant the vertical change. Now, we're always going to read our graph from left to right. So I'm going to start with this furthest left point that I have highlighted, and I'm going to count the rise, so the amount that we go up in this case, since my line is going up as we move from left to right. So I'm trying to get from this point over to my other point. So first I have to go up, and that's 3 spaces up. So I would say that the rise of this line is 3. And then from here I need to get over to that other dot that I highlighted, and that would be the run. So I'm counting the run here as we move over, and that is 5 spaces over. So the run of this line is 5. So because we have a rise of 3 and a run of 5, we would say that the slope of this line is 3/5. As we take a look at our next example, we've got a line drawn out on our grid, and I've already got a couple of points highlighted on that line that we're going to use to help us find the slope. And I've also highlighted what the coordinates are of those points, which might be helpful as we're looking at finding the slope of our line. So as we're finding the slope, just like we did on the last one, we want to find the rise over the run. Now what we should notice is that our line, as we read it from left to right, it's going down. So this line is going to have a negative slope. We're trying to get from this furthest left point over to our right point, and counting the rise, this time we have to go down a certain number of spaces. Now, counting up the spaces here, that's going to be 6 spaces. But since we're going down, it's going to be -6. Now, something that we can look at as we're calculating the rise, especially if we know the coordinates of our point, We said that the rise was going to deal with the y value. So from this top point, we've got a y value of 5, and from this bottom point, we've got a y value of -1. The rise really corresponds with the distance between those two values. So if we were trying to figure out how far apart 5 and -1 were from each other, that distance would be 6. But again, like I mentioned before, because this is going down, then it would have to be -6. So the rise of this line is -6. The run, we're calculating how far we're moving over, so going over to this other point that we've got here, and that's a run of 3. And we talked about the run, the left and right movement, being x values. So if we look at the x values, here we've got an x value of 3, and down here we've got an x value of 6. So we're looking at the distance between those two numbers. And the distance between 3 and 6 is 3 spaces. So this line has a run of 3. Now, one thing I didn't mention before is when we're dealing with slope, we always want to reduce down our fractions as much as possible. So we've got -6 over 3, and remember that fraction bar means we're dividing. So taking -6 and dividing it by 3, this line would have a slope of -2. Here's another example. So we want to find the slope of this line. We've got a flat horizontal line, and earlier on we said that a flat horizontal line was going to have a slope of 0, but I want to show you why that's the case. So as we're finding our slope, remember we do our rise over run. So the first thing we want to figure out is how far we're moving up or down as we move from our left point over to our right point. So if we look at this, and if we look at these y values, we should notice that they're exactly the same. So we're not moving anywhere up or down as we move from the left point to the right point. So we would say that the rise is 0. And the run, if we look at how far we're moving left and right, that would be a run of 6. We're going from -2 over to 4, so that's 6 spaces. So the run is 6. Now, when you take 0 and divide it by 6, and if you take 0 and divide it by any number, you always get 0 as an answer. So that's why your flat horizontal line has a slope of 0. Now, conversely, if we have a straight up and down vertical line and we want to calculate its slope, again, we're going to look at the rise over the run. So the rise, as we focus on these points, let's look at the y values. We've got a y value of 6 on top and a y value of 1 on bottom. So the difference between those, the rise here would be 5 spaces. And if we look at the run, well, this time we're not moving anywhere left or right. Each one of these points has an x value of 3. So the run is 0. Now, when you try to take 5 and divide it by 0, or if you try to take any number and divide it by 0, you can't divide by 0. That's something that you're not allowed to do, mathematically speaking. So anytime you see divided by 0, we say that that's undefined. Now, there is another way that we can calculate the slope of a line without needing to look at the graph and count the rise over the run. There's a formula that we can use. And in order to use the formula, what we need are a couple of points that are on the line. So I'm just going to give you general points right now. So we've got some x1 value and some y1 value. These are just general points from somewhere on our line. And then we need another point. So I'm going to call this one x2 and y2. So if we want to calculate the slope using the ordered pairs, so we're looking at finding the slope. Now, sometimes you're going to see slope referred to as an m value. What we're going to do here is we said that the rise was the difference between the y values, and difference means that we're subtracting. Now, what we're going to do is we're going to take the y2 value and we're going to subtract off the y1 value. And then as far as the run goes, we said that the run was the left and right movement, so it was the difference in the x's. So what we're going to do on the bottom for the run is I'm going to take the x2 value and subtract the x1 value. So let's use that formula now with these ordered pairs that we see over here on our line. Now, the first thing that I like to do with my ordered pairs when I'm using my slope formula is I like to label the ordered pairs. So this 2, -2 point down on the bottom here, I'm going to call this point my x1 and my y1. I like to label those to make sure that I get them plugged into my formula in the right spot. And then my other ordered pair, this is going to be my x2 value and my y2 value. Now, to calculate the slope, we're going to do this y2 minus y1 over x2 minus x1. So on the top of my fraction, I'm subtracting the y's, and I'm doing y2 minus y1. So my y2 value is 4, minus my y1 value is negative 2. Now if we look at the run on the bottom, we're going to take x2 minus x1. So my x2 value is 6, minus my x1 value is 2. Now if we look on the top of this fraction, we've got 4 minus negative 2. And when you subtract the negative number, that's the same as adding. So I'm going to switch this over to addition. So we've got 4 plus 2 on the top, and that's 6. Now on the bottom, we've got 6 minus 2, which is going to give me 4. Now I mentioned earlier that we always want to reduce down our slope fractions as much as possible. So if we're looking at 6 over 4, those are each divisible by 2. So if I take 6 and divide it by 2, we get 3. And if I take 4 and divide it by 2, we get 2. So this line has a slope of 3 over 2, or a slope of 3/2. A couple more quick examples here using that slope formula. So remember, to find the slope, it's y2 minus y1 over x2 minus x1. So in this first example here, I'm going to label my ordered pairs. So my first point, I'm going to call x1 and y1. And my next ordered pair, I'm going to call x2 and y2. So to calculate the slope here, we're supposed to subtract the y's on top. And we're going to do y2 minus y1. So my y2 value is negative 2, minus my y1 value is positive 2. Then on bottom, I do x2 minus x1. So my x2 value is 5, minus my x1 value is also 5. Now on the top, negative 2 minus 2 is going to give me negative 4. And then on bottom, 5 minus 5 is 0. So we have negative 4 being divided by 0. And we said that we can never ever divide by 0, so this line would have an undefined slope. Now as we look at our next example over here, I'm going to start by labeling my ordered pairs again. So my first ordered pair is x1, y1, and my second ordered pair is x2, y2. We're going to calculate the slope, so I'm going to start by subtracting the y's on top. So my y2 value is 4, minus my y1 value is 4. And then on bottom, my x2 value is negative 3, minus my x1 value is 0. So on top, 4 minus 4 is 0. On bottom, negative 3 minus 0 is negative 3. When you take 0 and divide by negative 3, you get a slope of 0. That's going to be it for this video. Thanks for watching.